Hello and welcome to the final instalment of our webinar series hosted by Vic No-TIll, focusing on relevant issues around soil carbon through a closer look at strategies to increase soil organic matter. This project is supported by the Wimmera CMA through funding from the Australian Government's National Landcare program. We'd like to thank them very much for their support. For those that missed last week's webinar with Graeme, we have it recorded and it's available on our YouTube channel. Today, we're joined again by Graeme for his sixth and final instalment. And Graeme is one of Australia's leading holistic land management and trading consultants who has had over 25 years of planned grazing experience and holistic management training. This webinar is the last, as I said, of the 6-part series. If you're interested in his previous ones, they're all up on our YouTube channel. There's been some fantastic information come through from Graeme, so I really urge you to go and check those out as well. So. On the topic of Q&A, if you've got any questions as Graeme's going through his presentation, please feel free to put them up in the Q&A box down. You'll find that tab down the bottom of your screen. Type them in and Graeme will address them as he's going. So for the last time, thank you very much, Graeme.
Great, thanks, Dan. That's great. I'll share my screen. Yeah.
I'll get that sorted for you.
Okay, thanks. So that'd be great. I was just going to do a bit of a refresh on some of the things that I've previously said and make sure that we had it all covered. So jump in at any stage. So I've got plenty of material, but anything that you want to discuss or get some more detail out about. And also just cover off on a few of the sort of the burning issues on what's happening in terms of policy and soil carbon. So I like to start with this. I find it's like a bit of a ritual for setting up for what we're trying to do, that the land needs to be, each day that you're out there, you need to be increasing landscape function and biodiversity, and nested within that increasing land is low risk, stable profit. How do we get that risk out of agriculture? It's the risk that's reducing our profits. It's not sort of the way we farm as much as designing it so that it's exposed to sort of debt, rainfall and market price risk. How do we design a way? I've got a real thing that no risk, no reward belongs in the stock market, not in biological and agricultural systems. So we need to really be thinking about how do we design, and then each day working on increasing the well-being of people that are working in agriculture so that more and more people want to do it. I still think it's sort of the most important thing we do. It's the basis of the whole of civilization. So we've got to be enjoying it and we've got to be making money while we increase the land. Last time I spoke about those barriers to profit, and it's sort of counterintuitive. It took me about 15 years to sort of realise that the best place to start if you want to increase your profit is just having a monthly meeting where you look at the variance to budget and take corrective action. So you've got to close that loop so that you do take the corrective action. Most agricultural advice underestimates the impact of debt, rainfall and market price risk. So we need to be designing away from debt, making sure that it's sort of got low risk rainfall and that you're such a low cost producer that the market price risk, you always make a profit. For grazing, convenient infrastructure is the first big barrier. And it's really making that so that it works. The one I did last night for the Goulburn Broken CMA, people are sort of using 2 wires for the lanes and then 1 wire for the front and back fences as they move them up the strips. And that's working really well. Animal phenotype then becomes the next biggest thing. So I'll talk about that in combination with the enterprise design. I really struggle to see how people can address animal phenotype if they're going to be a trading organisation. So one of the things is that you need to select animals that have a low maintenance energy, so moderate frame, positive fat, moderate milk for breeders, for females, for ewes and cows. But you can't do that in a trading enterprise because you're always trading them in and trading them out. So the majority of people, I've got to be a bit careful with my language, the majority of people struggle to get trading performance because with regenerative or landscape function grazing, because it's a different type of animals. The animals have been selected for production. So I think production is agriculture's nemesis or something. I can't think of the word. We need to, if someone says, I'll increase your production, I usually say, be afraid, be very afraid. Because if you focus on production, you increase risk, which decreases profit. Increasing production for most people, unless they're very understocked or very low intensity, decreases profit. So if they say to you, we will increase your production, then I'd be very afraid and keep away from them. There's a lot of confusion between agronomy and business, and it's because a lot of the agronomy practices don't take into account risk enough. So this is why I've put this last one here, and I've borrowed it from a paper on sort of soil carbon and no-till cropping, that evidence that gross margins increase farm profitability is not compelling. I really like that understatement that they use in some research papers. So it's not compelling because it doesn't take into account risk. It doesn't take into account the variation on your farm, and it doesn't take into account the failure rates and something else I was going to say and I lost it. It's actually someone else's safe to fail trials that they're talking to you about, not yours. So you have to use your gross margins on your farm as the design thing, not the gross margins from someone else. So this is this confusion between agronomy and business and gross margins and things like that. So people that use gross margins doesn't take into account enough of the overheads, enough of the design. It's got to be a full budget sort of to make this work and to do profitability. So I've put in this steps as I did last week, but it's really, that's a key step. Determining level of profit we talked about, but analysing profitability of your current, knowing your current profitability, not someone else's, not gross margins, yours, and what the risk is and how often it works. This one's just sort of, do you need other sources of income that may be not linked to rainfall risk if you've got a problem with rainfall? They could be simple and low risk and enjoyable. And then you just go through and do these steps. Happy to provide more material if people are interested in that. And also other things. So again, that monthly variance to budget, having that monthly meeting where you play the ball and make sure that you get budgets back on track. That corrective action, I work with a lot of people that they'll have a disaster, a tractor will blow up or something. And they go, oh, yeah, we're not going to make our profit. I go, no, this is when we start looking at what's the corrective action to take to put the profit plan back on track. So and a lot of people can get that to work, but it takes effort. To be like Dan and I were talking before we started that some people we talk to make our brains hurt. It makes your brain hurt working out, how do I get this profit plan back on track? Simple profit target. I pinched this from Mark Gardner up at Dubbo. Just what is it that what's your target here and how we're going with that? How to do that financial week link. Where is it that you need to focus your expenses? Is it on growing more crops and getting them through and not having failures from frosts and dry finishes? Or is it that you can't get the product off, or is it that you're marketing? If you're marketing into the commodity market, then the best thing to do is have a good agent. If you're marketing direct to people, then you have to be the agent. So you've got to just work out what that is. This has usually got a very low return if you're selling into the commodity pool. Some people can make that work more better for them, but usually it's getting that really good information and advice from an agent. And this is the form that we use for that monthly corrective action. So what was it? What was the variation? What was the cause of the variation? Because we need to keep thinking back into, well, what actually happened? And then what are you going to do to return it to plan, and who's going to do it and when? And, you know, can really, if you're doing this on a monthly basis, it actually improves your budgeting. And that wasn't what I thought. I thought we had to put all the effort into getting the budget right first up. And what I found was, both for myself and for our business and for a lot of other people that I work with, that the secret is to just start doing this. And you realize, oh, I'm missing, you know, I'm too short on that. I'm too underestimating the cost of that. All these other things start coming in, and your budgeting improves and you get better at it. So at the moment, a lot of people aren't budgeting and doing much work on that because they never meet the target. This tells you why you're not meeting the target and actually puts your profit plan back on track. Landscape function analysis. So this is the science. If we want healthy land, be able to read the land, do all those things that people are talking about. It's about looking at the soil surface. You know, this is where we get all our information about the soil surface. That's the leading indicator of what's happening in your soil. So we really need to understand and know this in depth, that if you don't want it to erode, it's got to be covered 100% of the time. It's water infiltration, it's got to be covered, but it's also got to have some surface roughness. And in a grazing situation, you're looking at the basal cover of perennial grass. So most of Australia was covered in summer growing perennial grass. So it's a really good thing if you're looking at doing some trials. I'd try some summer growers and typically Colin Seiss and myself would say do some trials with the African subtropicals, you know, so the better ones of those, because they've been selected for germination and establishment if you're going to do that. Otherwise, you can wait around for a while with the native grasses, even though Colin and I both promote Australian native grasses, especially the better ones like the box grass or warrego grass, as Cole calls it, the native Paspalidium. Then, you know, those type of grasses, you know, they work perfectly fine if you can get them up and germinated and established. And then, you, as I said, you need that little cover. For nutrient cycling, if you want to increase soil, if you want to reduce your inputs on fertilizer, you've got to start increasing the nutrient cycling. And the nutrient cycling is driven by the decomposing composting litter. So we've got to be really careful that we do this in the lowest cost, lowest risk way. Everyone understands that if they make compost and spread it, that it's going to be good for the soil. This is just growing the material in situ and then pushing it onto the ground so that it composts in situ on your land. Because then while you actually produce the compost, while you're actually making money with the grazing. So that's the secret for these big breakthroughs on how do I actually lower the cost of this. You can't make compost and bring it in and it be low cost and low risk. The way to do it is to learn to do it by growing enough litter, pushing it onto the soil surface with the animals with their muzzles and feet, so that then it can be processed by the soil and start to feed the soil and become sheet composting in situ. The costs and the cost to the environment, fossil fuel and money is too high on bringing and shifting around compost. So this is about doing it in there. If you want, in a grazing situation, then you're going for that basal cover of perennial grass, because they actually pump a lot of sugars. and actually get the soil going again. So it's that sort of thinking, how can we make all our expenses into income? How can we redesign is the level I like to work at. And that's all the relationship. So this is simplified. It's available at that link there. And David Tongway's put that up. So that link has all the material and more about landscape function than you ever wanted to know. David Tongway is very, very good at measuring soil. Do you know, he's incredibly accurate. He can actually see the relationships, but that's because when they measure soil, they actually pulled it apart and knew exactly what samples they were taking. It isn't a commercial sampling system the way David does soil carbons and things like that. So some of the coring techniques fail to reproduce his work because they're actually mixing up litter from the subsoil, litter from the soil surface, and then also getting subsoil samples in, doing all those. So this is measuring bulk density on a project he did with Helen King, who I got the photo from. It's very clear that in a grassland, a rangeland, grassland, pasture, as you increase the nutrient cycling, you increase the carbon. It needs to be ground truth. That slope needs to be ground truth at different areas, but it increases, as you increase nutrient cycling, increase nitrogen, you increase carbon. You also, as you increase landscape function, you'll reduce iron, sodium, and aluminium. You'll increase calcium availability. All those things balance up as you increase landscape function. We have not seen somewhere that doesn't happen. This is some work done by Peter Ampt and Sarah Dornbus on a Communities in Landscapes project that I was part of. And the pH fixed without adding lime, the extractable bray, the phosphorus was higher, the nitrogen was higher. It also shifts a lot more to organic nitrogen, which doesn't leak and acidify the soil, and the carbon and all the other work that we've done also shows that as you increase landscape function, you actually start to balance up the minerals. So I've got some work done up further by David Tongway showing how that works. As you increase landscape function, put more plants into the system, into the soil, sorry, not into the system, I had that. Into the soil, you actually start to regenerate the soil. So there's a lot of confusion and advice about you've got to adjust your chemical first, then your physical, then your biology. And it's just pulling it all apart. It's missing the point. You actually adjust the biology by increasing the landscape function, and the chemical and physical fix themselves. We've got a lot of examples of massive soil structure improvement just from 1 year of shifting to cover crops and getting higher landscape function. So, there's a lot of people still, I see it as sort of, I don't know, it's like some sort of stuck, leftover, input-driven correction of soil health. I find that if people dig pits, that they actually start thinking about what they can add into the soil rather than looking at the soil surface and saying, how can I change this soil surface to change the subsoil? So the leading indicator is that soil surface. And as you're managing, so if you had a healthy perennial pasture with large perennial grass basal area and decomposing litter, 30% of each hectare was covered with the basis of perennial grasses and decomposing litter in the intertussock space. And that decomposing litter had some visible fungal attack, so going to moderate decomposition. The first thing as you start to manage with too shorter recoveries or not enough stock densities, you lose the cycling of the litter. You lose that fungal decay, decomposition of the litter, then you lose the litter, then you lose the perennials. So stepping back up, you've got to go almost to that litter first, then the perennials will come. You'll create that better soil, moderate temperatures, more fungal component. Gabe Brown, when he's taking out, I know I mentioned Gabe a lot, Gabe Brown, when he's taking out an area that was for cash cropping and putting it back to his perennial prairie mix, God, I can't say perennial prairie mix. When he's doing that, he's actually does those back to back to back, 2 years of winter and summer covers, so that he increases the fungal component, so that putting it back to the perennial pasture mix is really easy. So we need to be thinking about all these things. How do we design a way? How do we stage a shift in our cropping and grazing so that we actually start to increase soil carbon, lower our rainfall risk, increase that resilience? It's not easy. And it needs to be thought through and planned. You need to be doing those safe to fail trials that I keep banging on about, where you're grazing that area at 1 sheep per square metre or 1 cow per 3 square metres for 2 or 3 hours until you feel like you've overdone it. It's a really good way to do it. So one of the things I've been thinking about, I don't know whether it works for people, is that you've got to drive it like you stole it, sort of thing. So it's only a small area. You've got to really get into it. You're trying to leave the soil covered, but you no doubt that the animals have been in there, and you think you've done it just a little bit too much. So, and then you lock that up, at least one of them locked up for 12 months, because it's that whole annual cycle of producing material, growing litter, and then repeating that actually allows you to see, how does my land respond if I mimic nature? So that's what I've been advising people. It increases, it's the fastest way to increase landscape function, and it's that whole root reserve driven recovery, not leaf reserve driven recovery, all those things that I've spoken about previously. At least do one trial, and if you do that trial and it doesn't get better, let me know, send me the photos, because I haven't seen that. So the only ones that we've seen that 9 months was better than 12 months was in Tasmania, and they had a set time. So they had a lot more biomass in the 12-month recovery, but they stuck to the 2 hours or whatever, rather than grazing it down to what it needed. Because this isn't fixed. This is active adaptive management. As you build more litter and a big, deep, stable litter layer, you need more stock density for longer each time you go through. So the exercise and the grazing that we do is not to shorten the recovery when you increase landscape function. It's to increase numbers intermittently as the seasons allow, to get that litter cycling and push it onto the soil surface. So, I've been trying to say to people, shortening the recovery when you get the land functioning, to me is like saying, I used to run 5 kilometres, then I got fit, so I went back to 2 kilometres. It just doesn't make sense in my brain, but I could be wrong. And you need to be always checking and having high quality feedback from your safe to fail trials. And you should see, that soil chemistry changing as a consequence of changing the management of the soil surface, which changes the soil surface and increases landscape function and associated biodiversity. That's okay. Any questions or comments on that? Sort of feel like I've had too many coffees this morning, so. Okay. I wanted to just talk quickly about this idea. It's been in the news a fair bit that they're talking about putting a tax into New Zealand for the methane emissions out of the livestock. And, we need to be able to, it's one of my burning things is that most policy that you see, so this is this is the way governments interact with people, is through policy. And so, but most policy has got no hope of success. I've worked with policy and at all levels, sort of from local levels to state governments to federal government. And you can easily convince people that that policy has got no hope of success and it's not going to achieve what they want. And yet they will not sit down and do the work to work out, well, what would a policy do? So I'll just try and quickly explain what that means and what I'm talking about. So here we've got methane emissions out of livestock. So I use Alan Savory's policy design and analysis, and I've just got the first question out of that. So policies are created to either solve a problem or prevent a problem. That's typically what they do, and this one's a classic. It's to solve the problem of methane emissions causing more greenhouse gas and climate change or global warming or however you want to describe it. So that's what they're trying to achieve. So is it identifying the cause of the problem? Is the first question that Alan asks. So what's the problem? The problem is climate change. Is this identifying the cause of the problem? Well, the cause of the problem in my world, with my research, is the inappropriate management of the livestock so that they're actually not sequestering enough carbon. So does taxing their emissions steer people to changing their management of the soil surface, their grazing management, to increase soil carbon? Because I've done those things before in previous webinars where I showed you how if you increase soil carbon even only a little bit, you tend to swamp all your emissions. So I've done that for a number of farms. It's not hard to do the calculation. I use Richard Eckard's carbon accounting tool when it was still in Melbourne Uni. I think it's in the state government website now. So the problem is, and if you go back through this, it's inappropriate management. So it's very clear that this is just such a broad brush sort of a tax that's really probably only going to go into sort of consolidated revenue, that it's not going to fix the problem because it's not rewarding the management that you want. It's only punitive. I have no problem with punishing people. I think we need to punish the land managers that are continuing to destroy landscape function and biodiversity. No problem whatsoever. I usually do that when people say to me, I don't want to manage like that. And I go, that's okay. As long as you pay for the damage you're doing to the environment, you can do whatever you want. And usually people get a bit upset with me at that stage because they're struggling to make profit anyway. And I'm saying, well, they've got to pay more. So I have no problem with that. But this has got no chance of success because it hasn't identified the cause of the problem and it's not addressing it in the process. It takes a lot of work. I will. I'll come back to that question. So we need to be really clear that sort of every time you look at a policy, you go, oh, what is the problem it's trying to address? Because it's usually about problems. It's not about positive things. And then, is it addressing the cause of the problem? So if you increase soil carbon at all, you'll swamp methane and enteric methane emissions, but you've got to increase it. You can't not do that. And the only way to increase it, the science is very clear that you have to increase the nutrient cycling index through increasing landscape function. And there's nothing about that in there. So one of those, and that note I deliberately included, even though there's a typo down the bottom, is that you've got to sit and think about this by yourself. If we discuss it, we go into detail, and we end up, whenever I've worked with higher level sort of policy people, they always want to discuss how to market it before they've worked out what it is that they're going to market. So they spin down into that really quickly. So I will, I always try and make sure that they have time to sit and reflect and then actually go through the steps. So identify the cause of the problem. Once you've thought about that, then it all starts to make sense that, you know, if New Zealand was serious about this, they wouldn't be taxing, they'd be taxing the late majority and the laggards, but they'd be actually doing training, rewarding management that actually increase soil carbon. So really shift all the tax system around. So if you produce food from land that's regenerating, increasing the landscape function and biodiversity, maybe you don't pay any tax and you get lower rates, or, you know, so actually sort of designing for what we want rather than just sort of taking more money for the things we don't want, because I'm pretty sure that it'll have the unintended consequence of doing this. If you tax those livestock emissions, I believe that people will increase their livestock numbers and make it worse. It's always an unintended consequence that the thing, they've identified that there's a need to do something, but they'll push it the wrong way, and the unintended consequence will be that it gets worse. So I'll come back to that question, just won't be a second. And you really need to know that we need to be talking about, when we're talking about livestock emissions, I'm not talking about efficiency where you're sort of trying to breed animals that are less, produce less methane. I think that that's sort of, there's going to be a bit of a worry if they do grain-driven feed conversion efficiency. What will happen is that it won't be replicated when they're out grazing on grass. I don't think that we can focus on sort of just, we need to do all three, but we need to do the third one the most. So efficiency, people are going to have to be investigating that. Substitution, you know, everyone keeps talking about the seaweed and changing their diets and things like that. Efficiency does really weird things like putting in irrigation and growing crops in Northern Australia that actually increases the total emissions of Australia, even though each kilogram of beef has got less CO2 equivalents coming from it. It's just nonsense. It's just like, if Australia was your farm, you're now producing more greenhouse gas emissions, working harder, using more inputs, lowering landscape function and biodiversity. It just doesn't work. So we've got to be really careful about efficiency thinking. Most of the researchers and departments and things like that focus on that one first. Substitution, so you're going to change the diet, you're going to modify that. Good stuff, another good step, but it's barely slowing the car down as it heads over the cliff. We've actually got to redesign it so the way that we farm, the way that we graze, the way that we crop increases soil carbon, landscape function and biodiversity. I'm sure you've got it, so I won't go on about it. So question from Dorrit Brown, can you see a route-driven grazing system work for a small herd of horses? It can, Dorrit, and I've got your email as well to get back to. One of the things that we need to be really conscious of is we need to mimic this. The problem I have with people with horses is that they worry about things that aren't important. So we always did this, and I actually, when I was in New Mexico in 1996, and Alan Savory said to me that horses are the most powerful tool we have for regenerating a grassland. And I looked at him and thought he was, you know, are you being funny, or, you know, and he was deadly serious, and they are, but I had to go home and learn how to do it. So you need to do that. I'll send a video that's just, I'm waiting for it to be uploaded, of horses being managed. And I've also, the chair of Stiper Native Grasses, or the president of Stiper Native Grasses, which is an Australian not-for-profit charity. She can use horses in a positive way. So but it needs some horse management, and you actually need to sort of make sure that they do what they do. But it's the same thing. If anything, they're better than cows because they're actually really good at pushing the litter on. It's got to be fully recovered grass. So I noticed in your email that it had the question about spring, do you feed them hay until the grass gets growing? Well, we would carry over feed from last year so that they had that feed at the start of growth for the new year. You've actually got dry feed mixed up with all the old feed, that's mixed up with the new feed, so that you're not scouring them and doing all those things. So yes, it definitely works. I've written an article for Holistic Management International on it, and done a lot with it. I just haven't had a chance to get back to your email. So yeah, sorry, back on this. So the other thing while I'm going through, sorry, and I'll get to some soil stuff and things in a second, that there's a really big thing that if we reduce CO2 emissions enough, that everything will be okay. And it's just not enough. Do you know, even if you completely eliminated CO2 tomorrow, it would take too long for it to restore. It would take too long to restore, to reduce that concentration of CO2 gases or gases in the atmosphere. So it has no leverage in decreasing higher concentrations of greenhouse gases. So technology is not enough. So we are at the forefront here. People will be coming to us, and they will want to know. I heard Richard Eckard speaking on a thing the other day, and he was saying, don't sell them, you might need them as offsets for your own. I think that we're underestimating just the role that agriculture is going to play in all this. So carbon neutral and offset initiatives are equivalent to just ceasing that. We cannot offset our way out of this. Do you know, we actually can't just reduce CO2. We can't offset and lock up other areas and things like that. It's just not going to do it. So, so we need to be thinking about, well, what is the role of agriculture? So this needs to happen. I'm not saying don't do it. I'm saying it needs to happen and happen rapidly, but we also need to be doing this. And on the land, this is where we come in. So that strategy of on the land, soils and plants, this is what we do. And it's very simple. This next diagram's a bit worrying for me, but the size of the arrows is the fluxes. So how much carbon's coming down through from photosynthesis, how much is then converted into organic matter, then how much is oxidized out of the soil and respired and oxidized by bushfires and things like that. This is the fossil fuel emissions and deforestation. So a little kick off there. So it's a small amount, but it's like a repeated trip into the system. But we control these things. We control the big arrows, not the little straw down there. So we are in charge of this. So what we need to do is massively increase photosynthesis year round throughout the planet, not necessarily on the same piece of land. I don't have the, you must be growing a living root all year round, which is one of Gabe's soil principles, because I'm not sure there's a lot growing, when it's -20 or -40 or whatever it is in North Dakota. And it can be very expensive. I have no problem if you've got a winter grass, a winter pasture that goes dormant over the summer and it's got lots of material and good landscape function, that it's dormant's fine. You know, there is no problem with that. So the majority of grasslands throughout the world spend more time dormant than they do spend growing. And that's not a problem. That's always worked. But when they are growing, we need massive photosynthesis. So, and we need it then to be managed. So this is where we intervene. So do we convert that photosynthesis into organic matter or soil organic carbon? That's what we're into. grow this, put it in here. And a lot of it's pumping through the roots. I have a real problem that a lot of the soil scientists and researchers on that are still using the Roth-Amstead carbon model. It's proven that it's not right. It doesn't have a biological, it's a very mechanical. It's sort of net primary production and then putting it into the soil. It doesn't work. It's not the way the world ever worked. But somehow in a system that's sort of making sure that you don't have much fungal decay, that you're actually thinking that that's representative of agriculture. So it needs to be the new contemporary agriculture where that's not an issue. This is what we are really into. Reducing this is also that loss of organic matter. We need respiration, and we need the plants respiring to cool the planet. So we need that. We just need to stop, increase this, massively increase this, and reduce that. And we will really quickly get a hold of this. So, the soil's contains more carbon than the biomass and atmosphere combined. I'm sure you've heard all those things. It still came as a shock to me when I was in working in the DPI that one of the researchers said, "No, you're wrong." And I go, "What?" So if I'd known what I knew now, I would have just said, "Google it, mate." He actually stood me up and argued with me that I was wrong, that there was more carbon in the soil than the vegetation and atmosphere combined. So just quickly, there used to be a no-till carbon market I think it was on the Chicago Board of Trade. But what they found was that no-till didn't necessarily increase soil carbon. It's got really good things. It's a great thing to do, but and that's why I pinched that evidence that it promotes carbon sequestration is not compelling. It tends to move the carbon around in the soil profile rather than actually increase the total soil carbon. So that sort of had a bit of when people were tilling, the carbon tended to be deeper. When they were no-tilling, the carbon tended to be near the soil surface, which is a good thing. I've just included this because to cope with that whole idea of you increase the plants and the biology, you'll increase the chemistry improve the chemistry and the soil structure. And I think this is even though it's just an experiment that CSIRO did, that it's really important to think, well, how can that happen? What's actually going on here? And we sort of know this, but sort of ignore it, and I don't know why. So this was, their model of the land in these low production environments is that you have this run off one area and run on to another area. So run off, run on. I don't share that sort of as a way that the land works, but it is sort of a valid, coherent hypothesis. So it needs to be checked. So this was what they were doing with this. So bare crusted, low organic carbon, all those sort of things out there. It's basically the subsoil that they're farming on out at Western Division, New South Wales. So you can drive for hours through this sort of country. I've driven through it on some of those really big properties, and took all day to find one perennial grass plant on these properties. This was just a cross section through the soil, showing that there's no soil structure, no vertical voids to allow the water in. It's just solid sort of solid block of soil. So I think that's really important to think about. This is what, if you dig that soil up, this is what it looks like in that top bit. David Tongway uses a paint scraper, not a shovel, and I'll try and talk about that. So he's only ever looking in that top profile because that's where the leading indicators of how your land management's going. And the others are consequences for, so poor water storage, low infiltration, high runoff and erosion. this is the soil organic carbon. So, and this is sort of showing the accuracy and sort of the way they stratify the soil carbon down through to that 100 mils, 10 centimeters. So this was at the start of the treatment, so start of the experiment, so soil carbon baseline. I thought it was pretty good carbon really for out there. So it's got that sort of, 1 to 2, 2 to 6, 6 to 10. So they actually pull it apart a lot and really accurately do that. This was the treatment, and it was really just to test that runoff run-on theory. It wasn't sort of a way of regenerating the land out there. And I've got photos and sort of lots of research showing this. I went through a lot of pooled country that had been chained, with the hot bush and things like that. And you'd see this quite a lot, that you would have these brush packs on the soil surface. So they'll put at right angles to the flow, which is how we lose that topsoil and seeds and nutrients as it goes, and slows the overland flow. It's like increasing the soil surface roughness in the landscape function model. So then some, perennial grasses germinate there without animal impact. I can germinate them faster using animal impact and long recoveries and high plant utilization, but they will germinate, so as long as they're protected. So people say nothing will grow, but that you only need to, when I drove across the Nullarbor to WA a couple of years ago, there was perennial grasses germinating and establishing green and thriving, even though they hadn't had rainfall and it was 46 degrees. So carbon sequestration into the soil is an active process. And I think that's the key thing that we need to be thinking about. This is about making something happen. And this is what happened in that 3 years out there. Of course, me being me, I'd argue that I could do it quicker by using animals than this, but this is, CSIRO peer-reviewed research. So you've got to be a bit careful. So in that top layer, they'd increase to 1% organic carbon. So then over time, this is where the place got to. So, and in the notes, the vegetation response after 10 years confirmed the concepts that you could capture all this. You can see that it's a bit proud of the soil surface, less erosion, more plants. It regulated the overland flow, so it was like mimicking surface roughness. Maintained a high above ground grass biomass, enabled high soil productivity to be achieved. But whilst maintaining wool production, sequestering soil carbon. So some of these areas could only be grazed the top parts of the plants. But this is the key slide that I wanted to get to, is that bioturbation, so the life in the soil and the plants in the soil actually increase the soil structure. So that's how we increase soil structure, not sort of not any other ways, not adjusting the chemical, the calcium magnesium ratios first, or, dragging a sharpened piece of steel through it. This is the lowest cost, lowest risk, most profitable way of improving soil structure, is with landscape function and plants. If someone can find a cheaper, lower cost, lower risk way, then please send it to me, because otherwise I'm happy to be shown to be wrong about this. But I think we intuitively know that it's about the plants and it's about the landscape function, and then allowing that bioturbation to happen from there. So, so this soil had a lot more of that vertical porosity. So, lower bulk density, and a lot of the organic matter starts to get included into that top centimetre of the soil. So as this starts to happen, you start to get a complete change. Sorry, that's what I wanted to do. Just skip back to the previous one. Tonight. Oh, let's see if I get somewhere. You get, this has got some material in it, but you start to get that open and friable soil surface. So it's always open. It's always open. It's starting to get more small particulate organic matter, and you're starting to get these pores that allow the soil to absorb water and hold water. And that dismantling of the physical crust, that capping across the soil surface that I'm sure everyone's familiar with. By having the plants there, you open that up and dismantle the physical crust. So it's a really important thing to understand that this is how we do these things. So, so we've got more carbon. It's starting to go down further. We know from work that we've done that at deeper you go into the soil, as you start increasing landscape function, that you get more carbon, a larger percentage increase in carbon the deeper you go. So we're going to need to sort of make sure that we keep an eye on that. So not just as everyone knows, this is now got to be done to 30 centimetres, and we're probably going to have to go down deeper, probably to a metre and things like that, which I found became problematical where we tried to do those deeper soil cores in those soils out in the Western Division of New South Wales. Any questions or comments on that? Anyone got any thoughts on whether there's a better, lower cost, lower risk way of improving soil health than through plants and landscape function? Was really what, I'm always searching for, well, this is what I believe to be true. This is my working hypothesis. What's the evidence say? And we've just got to be really careful that sort of I find that I lock in too hard and start believing that my working hypothesis fits all situations. So if anyone finds anything, I'd be really keen to hear. Just another update from Stephen Hobbs. So grazed with sheep on the end of March. Then just photos over time of this area. It's sort of just the latest photo that was from this week, or this Sunday, sorry. These photos, I haven't put the date on. Excuse me. Yeah, so it's still growing. There's variation. You should be able to spot these areas from Google Earth is sort of what I try to say. You want them to be so different to your current management that they stand out on Google Earth. And I've got sheep properties. So this is the control area. And this was sort of, soil moisture probes, but they were struggling with cockies, struggling with cockies on that. This was where the gate was. This is where the gate was for the trial area. So let the sheep in here, and they've trampled here. And this is what you see a lot of. So this should be different from the rest. It's had more animal impact or stock density, herd effect would be the language that Alan Savory had used. So it should go perennial faster. It should have a higher nutrient cycling index. As it recovers, you should see that near the gateways, is where you see the biggest impact. So in a, sorry, I'll just get this. Where these gateways are, sorry, I've lost my train of thought. Where these gateways are, usually when the grazing is degrading or is not regenerating the soils and the plants and promoting landscape function, you'll find that these gateways are worse. They're actually, and in the literature, it's called the piosphere, P-I-O sphere. So you get a gradient that closer to the trough or the closer to the gate or where they often travel through, that'll be worse for that. So it'd be more bare ground, less perennials. And as you go further away from the water point, you'll get more perennials and things like that. So that's the standard where grazing isn't being sort of restoring landscape function and biodiversity. That flips. So when you start restoring landscape function, and these areas that are getting that extra impact but extra recovery and extra plant utilization actually get healthier. So if you wanted to go on to someone that said, they go, oh yeah, we're doing some grazing management that's restoring everything. The thing to do would be to go to the next grazing area and see if they've got that effect happening, an inverse biosphere where they've actually got more landscape function and biodiversity in their gateways around their water troughs and that type of thing. So, sorry, I got a bit fuddled in that. And sort of we're also monitoring versus these areas as well. So we're sort of going to monitor all the three things. So any comments or questions on that? That's about all I had, Dan. So is there any?
Sorry, just shutting the door so the young fella doesn't come in. Is there any further questions? We've got a couple of minutes with Graeme. While we do that, I just thought I'd say thank you very much, Graeme, again for your presentation today. It's been fantastic again. A lot of good talk about carbon again, which I think is on the front or tip of everyone's tongue at the moment. So it's very funny you talk about how we got to increase soil organic carbon, and photosynthesis is one of those really big things, and we really need to increase them. And one thing John Kemp talks about is we've only really have peak photosynthesis for sort of 40 odd days of the year. And that's in a North American context. I think it might be less for us, I think. So we really need to look at production systems that we can increase that. And then, if we can increase that, then we increase our landscape function. And I think that comes into cover crops and that sort of thing, and try and have that green leaf for longer. And getting that rate up a lot with nutrition and that sort of thing as well. So sap testing and all that sort of stuff, I think will come into it. And once our soils are working well and delivering the nutrients that plants need, and the photosynthesis is happening at a rate that it needs to be, we'll see exponential gains, I think, with that. So So
I always thought it was funny down sort of where I was. The neighbours would spray out, like we'd grow 60% of our grass from the last week of September to the first week of November in southwest Victoria, so south of Hamilton. So it was like a real, it depended on the year, but it was about that sort of time nearly every year, and they'd spray it out. Like just as it was hitting its peak photosynthesis. And I try and explain to them, but they were trying to keep the moisture so they could grow their summer crop to finish the lambs on. So they just thought I was a nut, So peak photosynthesis, and they got bare ground, but they looked at it that they had more grass than they could eat. So why not spray some out? So it was a different focus, that's for sure. So
I think agriculture is in a really good position. I think, in the next 10 years, there's a lot of focus on net zero and carbon emissions and carbon sequestration and that sort of thing. I don't know if you've heard from Charles Massey, but I saw a presentation with him in Wagga just recently, last couple of years, and he said of all the different ways that we can combat climate change, agriculture and the agricultural storage facility that we have in our land far exceeds anything that modern technology can come up with. And I think you'll probably would agree with that, would you?
For sure. And I think we know the pathway forward through that increasing landscape function and biodiversity. That's the way to do it, So, like I just think that we'll just all be shifting to that lower cost, lower risk. Perfect.
Yeah.
Very good.
No, it's remarkable that Mother Nature got it right all those years ago, and then we come along and thought we knew better. So,
for sure.
Thank you very much, Graeme, for the last 6 weeks. Really appreciate your input into this series of webinars. Big thank you again to Wimmera CMA through the funding from the Australian Government's National Landcare program. So without your help, this wouldn't have happened. So thank you very much for your support. Just a couple of housekeeping things before we wrap up. The survey will be available in your window. If you could fill that out at the end, that would be much appreciated. Thank you very much. And thank you very much again for everyone's attendance today and over the past 9 weeks, not only with Graeme, but with David Hardwick for his Bugs and Brews webinar, as well as Jade Killeran's 2-part series on multi-species cover crops that we had at the start of the series. So if anyone wants to go and get any of that information, they're all up on YouTube. So yeah, if you want to go back and see them, they're all available. So thanks very much for everyone for your attendance. Thanks very much, Graeme. Been a very interesting 6 weeks. Learned a lot. Thank you very much, and hope to cross paths soon.
Fantastic, Dan. Thanks for that.
Bye.
Bye-bye. Bye.